So here we are done with the Kepler's laws of motion, and now we'll start with the next topic, Newton's law of gravitation. Well, this is also known as universal law of gravitation, right? Because it is universally accepted and applicable to all the objects in the universe. Now we know that in the universe we have small, larger, lot of objects, celestial objects, everything, right? We can consider Earth, Moon, we can consider chair, table. In all our surrounding, whatever objects are there, we can consider all of them, and this law is applicable to all of them, right? So what this law is about? So this law is about the force of attraction between all the objects around us. So is this law applicable to us? Is this law applicable to our laptop, our pen tablet? So answer is yes, this law is applicable to all the objects. So let us see what this law says. So universal law of gravitation states that every particle attracts every other particle in the universe with a force, right? So there is a attractive force between all the objects in the universe. Yes, now how to calculate that force? So the dependency of that force is also given in the statement, that this force is directly proportional to the product of masses and inversely proportional to the square of distance between them. That means this force is everywhere, but this force or the value of this force has some dependency on some factors. So what are the factors? So the factors is masses of object and the distance between them. And how the dependency is there? It is in direct variation with product of masses, and it is in inverse variation with distance between them. Now we all know what is the meaning of direct variation and inverse variation, right? So here if I am considering 2 point masses m1 and m2, and if these are the point masses, then distance between them is d. If these are some symmetrical bodies, then center to center distance we'll consider as d. Okay, so m1 is the mass of first object and m2 is the mass of second object, and you see here the force is applied by the second object on the first mass towards right, and on the second object we are having the force towards left, because it is the attractive force. So these two objects are pulling themselves towards each other. So this is the way we get the direction of force. And then according to the law, here we have written this mathematically, that this force is directly proportional to product of masses and it is inversely proportional to square of distance between them. Okay, so that means according to the statement, if we increase one or both the masses, force will increase because it has direct variation, and force will decrease if distance increases because it has inverse variation with the square of distance. Okay, so here if I say if one of the mass is increased or both the masses are increased, then force between them will increase. But yes, if I increase the distance, then force between them will decrease. So this way we have removed that proportionality sign. Okay, this was the relation we had. So we remove this proportionality sign and we get this, where we get the capital G. This capital G is known as universal gravitational constant, because it has the constant value all over the universe wherever you go, and the experimental value of this capital G is 6.67 into 10 to the power minus 11. What should be the unit? Unit can be calculated with the mathematical expression. G is given by fd square by m1 into m2. Correct. That means the SI unit is Newton meter square per kg square. So this is the experimental value of universal gravitational constant.